A 2.4 kilogram block rests on a 30-degree slope and is attached to a string of negligible mass to a solid drum of mass 0.85 kilograms and radius of 5 centimeters, as shown in the figure. When released, the block accelerates down the slope at 1.6 meters per second. What is the coefficient of friction between the block and the slope? So, we have a figure, something like this. Has an angle, kind of like that. It'll have to do theta. There's your pulley, and there's your mass. And so we have given little m is equal to 2.4 kilograms mass of the drum we have radius of the sphere is 5 centimeters or 0.5 millimeter, where we get over twice. And we have acceleration 1.6 meters per second squared, and they want us to find the coefficient of friction. Okay, so we actually have two things to set up. We have to set up a free body diagram, and we have to set up as well the picture around this pulley. So let's set this up. Okay, let's start by clearing this. Okay. So their picture looks something like this with the angle theta. There's your pulley. There's your mass m. So first the free body diagram, and we'll use different colors for forces. Okay. So our free body diagram, rotating it so that axis is normal. So axis looks like this. Mg is at angle, like this. Theta is the angle right here. And this is mgy x, and this is mgy. Now, of course, we have the normal force, which we'll use a green color for. Normal force here. Okay. We have friction. We'll use kind of this color. And then, I don't know, I'll use purple. And then retention, which is a little bit bigger, something like that. Retention. Okay. Next, we need to set up the pulley of radius r and the tension force. So this over here is our FBD, and this is the pulley. Acceleration in both situations. Acceleration going to the right in all, for definition, in all of our situations. Okay. That's the physics. So now that we understand this, let's understand what the physics is talking about. Okay, in the first situation, we have the component of weight which overcomes two forces, friction and tension, to have an acceleration. Okay. In the second situation, we have the pulley, which is the pull or the tension or the cause of rotation is the tension force on the string. So that produces an angular acceleration on the pulley. And because the mass and pulley are moving as one system, they will have exactly the same acceleration. Okay? So, now that we understand the physics, we can represent this mathematically. How? First, we find the sum of forces in the x direction, which is mg in the x direction, or being consistent by using the colors that we have. Okay. Minus tension, minus friction. Okay. And that's it for the forces in the x direction. Then we have some forces in the y direction. Which is normal force. Equals 0. Why? Because it's not jumping off the track at all. So, in this case, we have exactly this. And normal is equal to mgy in the y direction. And we'll find out what that is later. So we have the equations that we need here. And now we set up the sum of the torques equation. Well, in this situation, there's only one torque being caused by the tension, which is going to be R times T, like this. Or, to be consistent, like that. Okay. So as you can see, we have a few unknowns. We know the angle, so we know that mgx and mgy have to be written in terms of the angle. So if we could see this picture like this here, we can see right here, mgy we can see mgy is equal to mg cosine of angle theta, and mgx is mg cosine of theta. Okay? So that's where we're going to take and plug it in into where we see mgx and mgy. And we'll worry about the tension force in a minute. Okay. Okay. So it's first starting with the mgy. Right, so mg cosine theta is going to be the normal force. Why we need normal force? Because recall normal force times the coefficient of friction is, of course, going to be the friction force. So sum of forces in the x direction and at this point the colors don't really matter, so it's mgy sine of theta minus t minus cosine of theta minus mu mg cosine theta, like that. Okay. Now, the problem here is, of course, the tension force is unknown. Okay. So with that, we have to work with the torque equation here. That's here. I'll call the sum of torque is going to equal the radius of the pulley multiplied by the tension of that said pulley. Okay. And recall that this can be equated to this moment of inertia concept multiplied by angular acceleration. Okay, what I call Newton's second law for rotation. Angular acceleration is proportional to the net torque, or the sum of torques, and inversely proportional to its moment of inertia. So, using that fact, using acceleration is that we can solve to the sum of torques. Okay. Using that fact, we have RT equals I alpha. Alpha, angular acceleration, is the regular linear acceleration divided by its radius. So we'll divide it like that. And of course, if we divide by r, we end up with tension equals I times A over R squared. So we use the wrong color. Okay, remember that it's moving as a system, so the acceleration is going to be exactly the same for this, for the forces and the torques. Okay. Now that we know that, you can plug that in for our tension, and then use Newton's law for linear acceleration to help us find, of course, what we have. So, oops. Sum of forces equals sine of theta minus tension, which we just found it to be I A divided by R squared, and of course the coefficient of friction, which is nu mg cosine of theta. Okay.
Has arrived.
Alright. Now, using Newton's law, which I'm sure all of you have straight memorized at this point, acceleration of a body is directly proportional to its force and inversely proportional to its mass. And if you don't know that, God help us all. Now, so since we have this wonderful fancy equation all completely memorized, of course, equals sigma F divided by m. That's Newton's law. From there, we can state force is equal to mass and acceleration. Right? It's the implication, not the other way around. Recall that point. So now that we know that, we can start by doing that. So we have mg sine of theta minus I a over r squared minus mu mg cosine of angle theta whole mess is teal is equal to little m times a. And this a should do the same because we're all undergoing the same exact acceleration. Of course, now we're solving for the coefficient of friction. So anything that's not coefficient of friction needs to be moved to the other side. So we have mu mg cosine theta equals sine of theta minus I times a over r squared we'll use a blue for r squared. We'll use midnight blue for r squared. Minus ma. Okay. In this situation, m, and m are all the same, but you cannot cancel it, of course, because this I is in the way right here. This moment of inertia, we have a solid drum. Okay. So if I draw a drum, which is kind of like a cylinder, something like solid cylinder, something like that. In that situation, the moment of inertia, I in that situation we have the moment of inertia of a solid disk one half mr squared. Okay. So that will get substituted for our moment of inertia. Hold on. Window. I don't know. Now, we know that, we can plug that in to the equation right over here. So that 1/2 mr squared goes right directly in. Okay. So we have, after the algebra, mu mg cosine theta is equal to mg sine of theta minus 1/2 mr squared times a over r squared big M, by the way. So it illustrates that it is the mass of the pulley and not the mass of the block. And of course, minus little m times a, like that. Alright, r squareds are exactly the same. They cancel. And so from here, we can simply divide whole equation by mg cosine theta. Alright. And we'll get our coefficient of friction. So we have our mu equals, kills that. Sine divided by cosine is, of course, tangent of angle theta. Okay. Minus, and a is the same, so I can factor it out. So I can factor out minus a actually from here. Let's just factor out an a. Minus a times 1/2 m plus m plus little m. Right, because we factor out the negative. We factor out negative a from this expression. Over mg cosine of theta. Now, let's see if we did the algebra correctly to get the correct answer. Okay. So tangent of 30 degrees, I can already tell you what that is without looking at it. So tangent of 30 degrees is square root 3 over 3. Minus a, which is 1.6. 1/2. For m, little m, which is 2.4. Times big G, 1981. Cosine of 30 degrees, which is square root 3 over 2. Okay. Do all that, and you should get the proper answer to the problem. So, Doing the wonderful algebra, square root 3 to square root 3. Root 3. Subtract from parentheses 1.6 times 1/2 of 0.85 divide by 2.4 times 9.81 times parentheses square root 3 divided by 2, close it, close it. And we get 0.355. So we get 0.35, which is a reasonable answer for the problem. So we get mu, and there are no units to the coefficient of friction. So that's a reasonable answer for the coefficient of friction for the problem, because it's smaller than 1, obviously. Okay.